This session is on hidden carbon footprint of water, with humanity facing down global challenges such as depletion of freshwater resources and climate change trends. These targets or strategies will become ever more important and ever more urgent. This session will present a new version of the environmental impact of water use and move beyond the traditional focus on the water efficiency. It explores the relationship between water efficiency, embodied carbon, water quality, and carbon mitigation, taking into consideration resilient and net zero water design, strategies, and operation. This session features a diverse group of experts and international leaders representing North America, the UK, EU, and the Middle East, with significant contribution from the lead committees. We're here 4 members of the WE and EA tag. On the stage, I am joined by Rabi Al-Fadl. He's the Managing Director of ZEF Concepts and the CEO and co-founder of Phyla.Earth Limited. Virtually, I am accompanied by Rock Ridolfi. Rock is the chair of the Water Tag, the USGBC. He's an associate at the Engineering Economics EEI. I'm also joined by Daniel Howard. I got to know Daniel in 2019. He was the chair of the WE tag. Now, Daniel is chairing the Lead Fellow Evaluation Committee, and he's the principal at Human Building Solutions, LLC. Erin Rowe from the Netherlands. Erin is representing the EU. She's a member of the Water Tag, and she's the Sustainability Program Manager at North Shore. And also, we're joined by Ayman Shahata. He's the Sustainability Assistant Manager of the Red Sea Global. Before opening the floor to the discussion, I would like to provide an overview of the water carbon. I want to start the discussion by I want to start by the cactus. I've had that cactus at the cover page of the session. There is a small story I want to present for the cactus. In a couple of months or early this year, I went to visit a cactus farm with my daughter, Celine. She's 11 years old. We were, I thought she could discover some species of cactus, but it was a life lesson for me of that plant. It inspired me on how does this plant can survive in arid conditions. This plant is a water reservoir that can capture water from the soil and from air. These spikes have been evolved from leaves to get a mechanism of condensing water from air and finding its way to the stem towards the plant. This, for me, this is a net zero plant that can symbolize our journey towards the net zero and the climate action. It's also related to the water energy nexus. This plant has its own characteristics in providing the efficient mechanism in living in difficult or harsh conditions and staying glory. To get more, to start digging deep into our topic, for 30 years, the industry was looking into water efficiency. This evolved recently. We start going into water stewardship, water quality, and industries. Today's session is on water carbon.
So we have a lot of expertise. I actually have a friend working, so I might be a bit biased because I have a friend working on this project. And we, as a movement, started the whole district heating
The US
back in 2017.
and California, 1 in 5 power plants, almost 20% of the water pumps are used for pumping. Almost it's an average of 7%. It's a huge energy consumed for water. Okay. To have an overview of the water cycle, the water starts to be extracted from the water source from a stream. It's extracted to the water treatment through a portion of energy is consumed there, between 0.05 to 0.2. The water treatment is more energy intense. It's between 0.5 for fresh water, and it can reach 3.5 and much more for the seawater, for the salination plants. It's conveyed to the cities through a water conveyance systems, through pumping, depending on the altitude of the city and how far is the city from the water source. It's between 0.5 to 2.5 kilowatt hour per meter cube. Then it went to water distribution within the cities, between 0.25 to 0.5 kilowatt hour per meter cube to reach the building. In the region here, we store the water and we pump it. Boosting the water within the building, it's between 0.15 to 0.25 kilowatt hour per meter cube. At this level, we change stream to sewage stream. The sewage stream also passes through different water processes. That wastewater collection, the pumping stations consumes 0.05 to 0.2 kilowatt hour per meter cube. Wastewater treatment 0.3 to 0.8 kilowatt hour per meter cube, and then it's discharged to the source or any other total sewage effluent to be used. It also consumes 0.05 to 0.2 kilowatt hour per meter cube. It's an average between 1.8 to 6.8, has a big range because it depends on the water source and the city, and it's case by case. To transfer these numbers to carbon, we see that the water treatment and the wastewater treatment are the most energy intensive. We have an average between 1.3 to 7. It's an average of almost 3 kilograms per meter cube of energy consumed. If we transfer this figure to an annual figure for a household, from fresh water, a household will be emitting 1 ton of CO2 just from their water use. This, we did not add the hot water. What we see visible at the iceberg here is 5% of the iceberg is the 3 kilowatt hour per meter cube. The bulk energy is consumed heating water. 58 kilowatt hour per meter cube is water heating. But The good thing about this is that we do not heat all the water. 20% of the water consumed is considered heating. If we make a small correction for our figure, it's between 2.6 kilowatt CO2 per meter cube versus now it's 10.4 CO2 kilograms of CO2 per meter cube. The correction will be a household will be consuming 4 tons of CO2 annually. There is a piece of the puzzle, or 2 pieces of the puzzle still missing. The first piece is the energy consumed for power production. In the US, 11,857 gallons were used to produce of 1 megawatt hour. This figure gives us a figure of 45 liters per kilowatt hour consumed for power production. This is the first piece. With the second piece of the puzzle is these plastic bottles. The drinking water is a different stream that we're using. Please turn slide. Okay. Transferring drinking water throughout the cities is another concern from an energy perspective. Turn slide, please. Okay. The production of one plastic bottle consumes almost between 0.3 to 0.7 kilowatt hour per plastic bottle. If we assume that we need 3 liters of drinking water per person, annually each person will be emitting half a ton of CO2 just for drinking water. To go further, I'll send the floor to Rock to present the water emissions, the carbon emissions. Rock, you can hear us?
Yep. Thanks, Ibrahim.
Yeah.
So next we're going to jump into, again, a little bit more of investigation on the scope emissions. Essentially, like what categories of water and energy are we focused on when we're like breaking up a building's energy use related to water type systems. So on the screen here, you kind of see a very simple breakdown of the different scope emissions. Scope 1, it's burning, the direct on-site. Scope 2, some of that indirect relationship with emissions, that purchasing a like electrical grid. And then scope 3, it's like, so where and how are we evaluating water? What's our impact on site, but how is it contributing to potentially others? Like how our scope 1 and 2 water consumption may impact somebody else's like scope 3 emissions? And then how do we break that down and categorize it? So first starting out, what we're going to look at is scope 1. And again, from a building operational perspective, we're looking and evaluating the different types of systems that we're designing on that right-hand side of like that water diagram, as kind of broken out here. You have scope 1 and 2. That's that little box, so that's your little building. What's in my control versus what do I not have like direct control over, like that whole water treatment system, the pumping, the utility side of things, and really trying to piece it all together in one succinct kind of diagram allows us to hopefully start to understand that the decisions that we're making at the start of a new construction design or within existing buildings retrofit, it does impact the entire water cycle. So of one building at a time, we can start to make some influential impacts to the entire water system within our community. So in scope one side of things, from a building, if you could stay on scope one for a moment, please. What we want to consider is on the types of systems and the fuels that they may or may not need to actually consume. Like on a hot water standpoint, can we heat water to standards needed within the building using alternatives other than natural gas, propane, or diesel? Are there ways that we can incorporate, tie it into other heat pump type systems where the fuel mix is a bit more, environmentally friendly? Is it even needed? Can we shift to an electric type driven system? The other thing to consider is things on the water pumping side of things. So not just, again, in our building footprint, within four walls, but also on the site as a whole. Like, are there things that we need to consider from the ways that we're moving and distributing water throughout our building? Scope two, please. So again, continuing focused on now scope two emissions from a building operational perspective, we're looking at things that we're doing again on site from an electrical standpoint that may have some additional impacts to again other scope three emissions. So things like on-site water pumping, like where and how we're sizing systems, where are we locating them, truly understanding what the pump demand, what pressures are we dealing with, where and how we're distributing water throughout a building, can really do and have an impact on our overall long-term emissions for our original designs, if you will. So things like booster pumps, irrigation pumps, how we're handling, if need be, well water. We're also exploring ways, of like what you're doing on site from a water treatment perspective, and then we can get into the evaluations of, do you do on-site water treatment? What's the value of that versus a broader scale community-based type water treatment program? Is it needed from a community standpoint? Are there ways that we can consider alternatives to water treatment where we can reuse some water on site while using and distributing or disposing of wastewater that needs that extra level of treatment, while reprioritizing and redesigning systems in our way of thinking to accept some maybe a tertiary level of treatment at the site level. With wastewater treatment comes in pumping systems, any sort of chemical treatments that may be needed on site. But often, if we can start that conversation early enough, we can get a better understanding of where and how we can, both from a policy standpoint and from a water treatment quality level, use water throughout our building without it ever kind of leaving the site again. We also are considering more use of electric water heaters, some sort of heat pumps under scope two, please, still, with additional opportunities there. Newer technologies are improving. Its interconnection with some of the other HVAC systems is becoming more prevalent as we see buildings trying to holistically achieve longer term overall performance goals within their facilities. So like really trying to understand, go through the process. When you do a replacement in one, can you do a broader system, reevaluation, and maybe tackle a few things, especially trying to identify and really encourage the use of different incentive type programs, rebate opportunities that may exist to really emphasize the value of not just how, the water that we use, but how we, heat and control the water in our building. Same on the water cooling side of things. It's a big part of it. Scope three, please. Thanks, Ibrahim. So from a scope three perspective, it's still on the building operational, review. We're looking now beyond like our building, outside our building footprint, and considering again that whole, utility water supply. How is water being distributed and brought to my building, and then what's happening with it afterwards, after I'm done with it. After you are seeing that through the irrigation system, it's processing through your HVAC system, you're flushing it down, literally flushing it down the toilet. what happens to it, how is it controlled, trying to understand the entire, water diagram, and again, your overall perspective of it. Can help again from a human behavior understanding perspective as well. So you're also looking at the evaporative cooling, different opportunities there from a design standpoint, considering things like district heating and cooling systems. How are we handling process water cooling and heating, not just from the cooling towers, boilers, but any other process type equipment within your manufacturing or industry? Slide. So shifting gears now to that more new construction where a lot of conversations in industry are shifting to or trying to really grasp, like, okay, if we're talking about embodied carbon, water's got to be part of the conversation. And not just from a building operational perspective, but from like a during construction, are we considering, the impact that our water use during construction has on our holistic building embodied carbon for that project? What is the water intensity for that? So under scope one, you're thinking more like on the on-site water, sewage, water pumping during the construction, any fuel-based powers that may be used to, pump water, throughout the facility. Scope two, which may, again, on the scope one, you may not have electrical power on site yet. So you may be burning fuels to pump that water, distribute it throughout a facility. On scope two, you're looking again still at the on-site water, the sewage pumping, any sort of dewatering or dust control, those types of things, and maybe electrical utility consumption on site again, and then any sort of wastewater treatment you're going through during that time. And scope three, again, you're still potentially connected to a water supply, or you're, again, using tanker water to being brought to the site to control some of those things. Now, how do we capture all that? And next slide is, we really want to get an understanding, and you'll likely consider doing something like this, a water balance diagram, a water model for your project, and do it alongside like potentially an energy model as well. And there's a couple of reasons to do that, and they emphasize, at least from my perspective, you're trying to level set water with energy, and the two kind of coming together to help drive better design decisions for the project. So getting a good understanding of not just the energy systems that we're selecting and their energy demand and their energy consumption, but also comparing that, aligning it with a water perspective. When I make a decision on the energy side, does it have a water impact? And if so, let's get to a point where we can understand not just that water consumption, in cubic meters or, K-gallons. It's the water use itself, but also an emissions factor component to it. And it's something that we'll dive into a little bit more. But those are the factors that we're seeking, from the industry as a whole, in trying to obtain some regionally based, good, up-to-date factors on emissions tied to like our water consumption processes and how we're using it. What does it mean in my market? Again, taking a perspective, not just in my building, but again, the water that I use within my building came from somewhere, and what systems were used to create or generate and treat that water to my current building standards. And are there opportunities to say, I don't need water from my water treatment because I don't need it treated to that standard. I could reuse something on site and maybe reduce some of that opportunity or some of that emissions burn that way. So that's where we'll shift back back to you, Ibrahim, for some panel discussions.
Thank you, Rock. To get the discussion deeper now, Rabia, I will start with Rabia, and we'll take the perspectives from the UK, the US, the EU, and from the Middle East. I'll start with Rabia, representing the UK perspective. Rabia, what are the challenges from the global perspective, and what is the regional mitigation from the EU that government should address?
I can talk about the UK a bit more than, unfortunately, but yeah, we just. Let me give you a very quick sort of context of, let's say, snapshot of the UK in that sense. If you look at the annual mean temperature in the UK at the moment, it's about 8.8 degrees Celsius. Expected to be by 2050 between 9.1 11.7 degrees Celsius. Now, going back to the impact that it's going to have, being evaporation, cooling, and a number of other issues, this is immense, and that will have a big impact again, as has been explained earlier on the carbon. If you look at the probability of heat waves, from 10-20% is going to be nearly 40-50% in 2050. So we have by far much more probabilities of heat waves. Again, the impact is going to be immense on the carbon, water, then carbon side of it. Now, the people in significant flood zones at the moment, they are 1.4 million. They're expected to be nearly 2.8 million. And that is going to squeeze even people into smaller zones. And then there will be more density. And by the way, more density is a more difficult of management when it comes to water. If you look at the agricultural land that's classified to be not fertile or poor quality, it's 2% at the moment. It might end up to be 43%. But to end up on the water supply, in the UK at this stage, we have a supply/demand surplus of 1.4 billion litre of water. Is expected to be nearly 3 billion litre in deficiency. Now, again, that is a bigger impact. By applying those sort of impacts into the formalization that we are talking about, then we can start to talk about it. But the biggest challenge is data collection, is innovation in the way we're doing things. The problem that we are facing is still perspective, fragmented way of dealing with things. We haven't really tackled the system or the holistic approach to the matter. I think that is from the UK point of view. So,
what mitigations from government that
the governments are trying to find investments into a number of things. One of it is if you look at the leakage side, which has been mentioned, we have 350,000 kilometers of main water supply about to fail in the UK. So there will be a lot of investment going into that very one. And it means a number of other issues. If we go back to the same scenario, doing it the same way before, we will have by far more carbon emission than we are anticipating. So the government are trying to find more investment into that. We have 625,000 kilometers of waste water pipelines are failing as well. And then we need to tackle this very one. So they are trying to approach that as soon as possible. Are they approaching the right way? We still think is not approached in the holistic way, is still not finding the leaders for water. So there are a number of sort of issues that have been trying to work on, but it's not there yet.
Thank you, Rabia. Shifting gears to Europe, Aaron, knowing the EU taxonomy and do no significant harm, can you give us the perspective from the EU perspective?
Sure. Yeah. So also to give some context on challenges in the EU, I think water stress and scarcity are extremely prevalent here. I think last year was the hottest year on record, and this led to water scarcity in many areas, especially the Mediterranean regions, but also in Western Europe, which is experiencing poor conditions across many large water basins and shortages of water in places you wouldn't think of, like Germany and Belgium, as being traditionally water stressed. The causes of these vary a bit, and it's due to many, many factors, but I think two big ones. The one is man-made barriers. So the EU has the most broken river landscape on the planet, with more than 1 million barriers in place. And those are put in place over time to deal with things like increased population, to supply water using concrete piping from one area to another, but also in response to things like flooding events and irrigation needs, these sorts of things. But this prevents natural water flows and causes further degradation to water ecosystems and further stress by climate change. But the other big cause is increased water withdrawals. And in the EU, the biggest piece of the pie, I would say, as far as water usage is associated with energy, food, and industrial sectors. And water, especially in the energy sector, which is what we're really focused on today, is a key constraint for the energy sector, because currently water is used in power plant production with cooling systems, especially in fossil fuel power plants. So 40% of water in the EU is used in the energy sector currently. And then on the other side of things, the energy consumed to collect, pump, treat water represents around 2.5% of EU electricity consumption, which might seem kind of low, but overall it accounts for 30 to 40% of municipality energy bills. So it's a huge cost and a huge burden to taxpayers, to governments, and yeah, it's hard to determine the true value of water right now. But as far as mitigations go, I think one of the big initiatives is recognizing the true value of water, not just direct usage, but as we're talking about today, that indirect value of water related to carbon and energy and ecosystem impacts, because it's not just, rivers are running dry, lakes are drying up, but that also has an economic implication and a social implication on areas that are using those as tourism revenue and for their livelihood. But another mitigation is water management and planning. So there are some directives that have been in place for a long time, but they're under kind of government revision around protection and restoration of freshwater sources, but also really focused on increasing monitoring and data reporting transparency, because right now I think water is really kind of behind like the energy industry as far as metering and monitoring. So it's really hard to make decisions without the full picture and the data. So I think that's a big effort. And then one that's not necessarily focused on water, but decarbonization of the energy sector will have a big impact on water usage, especially if we start to move away from fossil fuels and towards renewable sources that don't use a lot of water, like wind, like renewable energy, and finding ways to store that energy. That could lead to 30 to 40% reduction in water use overall. And then the last thing that you mentioned, Ibrahim, is EU taxonomy. So this one is, I don't know if people are familiar with it, but the EU taxonomy is a classification system for business activities in the EU. And basically the EU Green Deal is an overarching kind of a piece of legislation that has several targets and objectives associated with it to reducing impacts of climate change. But one of these is the EU taxonomy, and it basically looked at business activities to determine which ones need to transition the fastest to be in line with the EU Green Deal objectives. So as part of that, like I work in data centers specifically, and data centers, you need to disclose information around a certain set of criterias in order to be deemed or defined as sustainable by the EU taxonomy and the Green Deal. And so they have a set of 6 objectives overall in the EU taxonomy, which are climate mitigation, adaptation, water, circular economy, pollution, and biodiversity. But when you, for example, in data centers, the real focus for criteria, I think 3 of the 4 criteria are focused on climate mitigation. So really focused on energy, refrigerants, and reducing those sources of emissions, but they also need to meet what's called do no significant harm. So if you're putting a lot of effort into reducing your energy usage, you need to also document and prove that you're not doing significant harm to the other 5 objectives, and specifically water for data centers. So if I'm, replacing my cooling system to get away from refrigerants, to get away from electrical compressors and replacing it with water-driven systems, then, looking at that balance to make sure you're not increasing your water usage factors by a significant amount is really important. And I think it's a starting point. Right now, there's no penalties and it's a disclosure type requirement, but I think it will really start to drive industries to look at this balance across not just one specific kind of piece of climate change or carbon, but expanding that out to water or pollution prevention, biodiversity.
Thank you, Aaron. To offer a different perspective, let's shift let's hear from Daniel. Daniel, the challenges at the US, knowing we have thousands of water utilities at the US, and the challenges, and there are a lot of research being there. Can you provide us the challenges and the mitigation from US or the North America?
Yeah. I actually wanted to kind of, so I spent many years, as you guys know, working with a water utility in a local regional water entity in the U.S. Southwest, in Las Vegas, in Las Vegas Valley, one of the areas that gets about 8 centimeters of water a year. So it's a very dry climate. But I've also had the advantage of working globally and being exposed to several markets and how those differing locales prioritize their efforts. So what I really wanted to share is the value of potable water as a resource largely runs in stark contrast, considering our access to it, to what we've seen from the UN with water determined as a basic human rights. Many locations around the planet do not effectively respect how precious water is. And some countries even have no real way to pay for their necessary infrastructure for water because they had no respect for the value of the water. So that embodied energy and carbon within water is not really well understood. And I really applaud you and Rock and Aaron for the work you did on putting together the introductory stuff to this session to try to get the people who are viewing the session understanding that the quantity of resources necessary, to transport water, to treat water. And generally, that's poorly understood globally. And sadly, I've seen that in Asia. I've seen it in South America, Central America, North America. I haven't worked a ton in Europe, but I've seen it in a massive way in other continents like Australia and in Africa. So as a consequence, that waste of water, of potable water, the water that we use in basically, it has the greatest level of embodied carbon, being rampantly, wasted in many of these locations around the planet. And, I know that in the region I'm in, with only 8 centimeters of water a year, there's always that concern for how do we go about developing sources of new water? It's very costly. If we're drilling deeper wells, we're using desalination, and even, condensation techniques are being, tried and proven out, but at great expense globally to gain that access to water. So really, that funding for development of advanced techniques to treat water, develop new resources, recover embodied energy utilizing, our embodied carbon advantageously in a circular manner is a great need. We're seeing methane being released because of global warming, and we're not knowing how to effectively address that addition of carbon impact. In one of the key things we need to do is be more effective on what we do to utilize water more effectively, for agriculture and to scale abilities for our population globally. With regards to what goes on in the U.S. and the Southwest, I guess the 20 plus years of drought are really straining on almost every area on what to do. And again, we're seeing a greater amount of carbon related to the extra energy used, as you presented earlier, on moving that water and facilitating. And then the other impact that we have as well on the unnecessary treatment of water to be treated to a potable standard, when in reality, a tertiary level of treatment is more than sufficient, certainly for us to provide irrigation and flush valves and, many things like that. I'll close that whole thing with, I've worked on several, numerous LEED Platinum projects and several Living Building Challenge projects. And really that whole idea of what can you do more effectively with water in every attribute that's been covered so far is stuff that we need to have on our checklist moving forward.
Thank you, Daniel. Back to you, Rock. From the U.S. perspective, you and Daniel, you're covering from the North America. Give us more about the challenges and the mitigation.
Yeah, thanks, Ibrahim, and Daniel. You covered it, very well from the general U.S. perspective, especially in an area that's very water challenged, water stressed, in fact, in many cases. If we can go and potentially like zoom in, it's not even like country by country or even like part region by region. We're all facing very similar challenges, just maybe different scales. And if we look at it, it really comes down to the challenges are from an individual's perspective in a sense, and it's like, how do we personally value water? If you have the luxury of having readily accessible, relatively inexpensive quality drinking water, you may not truly value water to the extent that it really should be. It becomes, potentially even an intangible, if you will, where you're not applying the real value to it. And you contrast that against the individual or a community that their water is their lifeblood to their agricultural, to their industry, to just simply having access to clean drinking water, and the two are completely their water problems. They need to be managed and handled completely differently. Your approach and your overall approach to how you educate, how you incentivize water is different. So what can organizations or governments help do? From my perspective, it's a continued outreach to those, I would say, water indifferent communities, where it's just you need to educate those groups of, if you're making design decisions, if you're contributing to that potential water stress in a community downstream, if you will, you need to be more conscientious of your individual's impact. You need to have a better relationship with water in general. Further on the water stress community side of things, it's again education, but also identifying and perhaps even contributing to incentivizing, subsidizing like low flow products that get those into homes and into communities that may not have readily access to those, or may not have adopted those types of systems yet. So it's like an education side of things, still heavy education. And again, if you're in a water indifferent type community, you may not have the incentive to encourage or fight for more policy, more governance around water, because why would you want something that you get so cheap already to potentially cost more based on more regulations? So it's kind of, you have to approach those conversations differently. I think it boils down to as simple as that, is we need better education, and better perspective, and individual relationship with water.
Thank you, Rock. Shifting gears to the Middle East.
Hello.
Desalination is a big concern, Ayman.
Yes, of course.
And
of course.
Yeah, and the region here is one of the most water-stressed region in the world. Give us the Middle East perspective and what challenges and the mitigations the governments are doing. Thank you.
Okay. So I would like to start with some fact about the Middle East region. It is located in an arid environment, and it only contains 1.4% out of the world's fresh water. And as you say, it is considered to be the most water scarce region in the world. For example, in the last 30 years, the rainfall percentage in much of the region has dropped by more than 15%, with a very high evaporation rate existing here. And so when it comes to water sources and management, the Middle East faces significant challenges, in my opinion. Some of these challenges are the over-extraction of the non-renewable groundwater sources, sources, which will lead to a depletion in our aquifers, in addition to the climate change impacts such as the increased temperature and the reduced rainfall. And let us not forget about the rapid population, which put a high pressure in the water sources in agriculture, industry, and domestic use. And all of that led many Middle East countries to heavily rely on the desalination plants. And as you know, the desalination is an energy intensive. It requires a substantial amount of electricity, which unfortunately making the desalinated water as a big source of indirect carbon emission. And indeed, there are other challenges and hidden aspects of the carbon emission associated with the water management in the region, such as the agriculture water use, the wastewater treatment, and the transportation of water. But to go back and answer your second part of the questions about the mitigation, where addressing this hidden carbon emission from a water-related activity is essential, in my opinion, to a holistic approach for sustainability in the Middle East. Governments in the Middle East should not only focus on the immediate water challenges, but they also need to focus on the associated carbon emission with this water management activity. They should prioritize first the water management and conservation. They must invest in the development and management of sustainable water sources. And they should promote the water conservation by implementing policies and technologies that promote water conservation in agriculture, in industry, and domestic use. This can be reached by many ways, such as the smart irrigation system, or the water recycling, or even the public awareness campaign. And the transitioning to renewable energy sources and the climate resilience and adaptation are also a very high mitigation priority that the governments should take into consideration. But let me end my answer by saying that using an integrated and holistic approach is crucial for ensuring the long-term environmental and sustainability for water resources in the Middle East. Coordination and collaboration among Middle East countries is also crucial to effectively address these regional challenges and achieve lasting positive outcomes here.
Thank you, Ayman.
I want just to add something. I think it's great to hear the full sort of perspective, and I'm so glad that the holistic came at the end of this conversation a bit more prominent here. I mean, every single engineer or designer will start from the life of the drop of water from the beginning, from the design side of it. So from the pumping, working on the inverters, frequency of supply and demand, sizing the pipes, looking at the filtration, the valving systems, all this, they need to have a top professionals working on that, everyone, we know that. And that needs to be really addressed more and more. The thing is, when you look at the sustainability framework as a whole, between energy, water, waste, the biodiversity, ecological side of it, material procurement, transport and movement, and the wellness indicator, you will find out that one of the main anchor out of these sort of topics is water. It's across all these sort of topics. It's not just only it's interactive with everything else, is actually very smart with everything. So water, it needs energy to be pumped, but at the same time, water in its full cycle, look at the water treatment and what we can come out of biofuel coming out of it, it can contribute back into it. So there is a lot to talk about in here, but again, when we talk about a carbon per cubic meter, we need to be aware of the wellness indicators required per region. It's the last discussion was about how much scarce the water is in the Middle East in here. And therefore, I cannot give it too much weight on the carbon till it reaches the wellness indicator required. Then you can give it different sort of factors. So there's a lot to talk about and to discuss, making sure that delivery for the wellness is achieved. And then we're talking about the carbon in the best possible way. But I'm so glad that this topic has been open because it's immense. It's fantastic, and I think it's been presented from the beginning well. Thank you.
Thank you, Rabia. As a developer or an owner, what's the benefit that an owner or developer can get from addressing water carbon? Why should they care about? Let's start from Rabia.
Okay, I think we struggled for years in the energy sector to convince developers, owners, to be more efficient when it comes to energy. That was for 20 something years, is not an easy one to go for. But again, with the carbon trading to a certain extent, it started to make sense. But the one that was really catching the developers more, I'm talking about the construction industry, was the premium of having an efficient building. That is one side of it. The other one is developers, they start to find a place making money in the EPC. So they can really charge on a kilowatt basis and having much more efficient. Now, are we able to get that when it comes to water? There is a lot of attempt, but there's still a long way to go because we need to link, and this is the approach and whatever is being done today. Will link A to carbon, B, it will link to some premium what will be required. C, we need to rethink of the settlement. And of course, there will be different type of water demand on the sector side of it. There is a way by linking more and more, educating more and more, and having more of a carbon money coming into the water side. But it's linked as well to biodiversity. It links to other aspects that we might, on the positive impact of it, throughout the whole life cycle of this drop water coming into it, we can squeeze money coming into it to feed into the subsidy from that end.
Thank you, Rabia. Building on that point, let's hear from Aaron, the EU perspective on that. Why owners from Europe should care about water carbon?
So I feel like this year I've spent a lot of time learning all of the ESG regulatory requirements that are coming into play here in the EU. So I think this is a big reason to start addressing this from an owner perspective if you're not already doing it, because you're going to have to in the near term. So, for example, in the EU, the Corporate Sustainability Reporting Directive is a non-financial disclosure regulation required for business owners above a certain threshold in size, but the energy impact associated with water is reported as part of this in your scope 3 emissions. So I think it's one of the first regulations out there that is requiring not just scope 1 and scope 2 disclosure, but also scope 3 carbon emission disclosures. And that does include water, the energy impact of water transported to your site. So I think even though the EU might be a little bit ahead as far as regulations go, other regions should also be starting to do this because you're going to have to. And I think similarly with energy efficiency, as was just mentioned, that started out also through directives and regulations and codes to get to a certain point, but now there's starting to be penalties introduced for not meeting certain requirements. And I would expect sustainability reporting to start to have similar requirements down the road. So I think getting ahead of that early makes a lot of financial sense from an owner and developer, as well as like a social impact sense and environmental sense. And the other thing I think that is part of also the CSRD is assessing your climate change risk planning and mitigation. So I think in the long term, if you're building a new site or building a new building, looking at it from the lens of like the water stress of your region, and do you need to be grid independent or water independent, and thinking about those investments, it will have in the long term cost benefits as well as resiliency impacts to your business.
Thank you, Aaron. Daniel, do you like to add anything on this? Daniel, you're muted.
I was doing a good job of monologuing there as well. I apologize for that. But, I think that when we start looking at, what benefits we can gain, and Aaron touched down on ESG, and I was just doing some training in Singapore on ESG, sustainability, and circularity. And really, the whole stuff rolls in. And it was really surprising, and Aaron was just talking about the complexity of regulations for ESG. And really, when we start looking at those impacts and the need for transparency, It's not something that's small, you know. So when we start, as Aaron shared, you know, risk mitigation planning, we need to be forthright with doing it and moving forward and really helping society in that regard to sort of get the bigger picture of what we can do and what we should do, and then realize that we have a big climate challenge that we need to address with regards to water and our care of that resource and what we can do.
Thank you, Daniel. Back to Rock. Rock, in what ways can the impact of water be addressed from the end user perspective? And how can LEED or other green building rating systems be used as a tool to aid in this process?
Yeah, good question. I mean, we need marketable rating systems, you know, to help emphasize or just package the efforts that are being made. It's an extra level of step. Like we can say, yeah, everyone should do this. These things are good, but a lot of people like to be able to say, okay, this is what I did, and there's somebody else that is validating what I'm doing. So programs like LEED, other green building rating systems, you know, have are essentially our proof of concept. You know, it's here's what programs that are collecting best practices from around the globe. They're saying, or at least regional specific, best practices. They're saying, do this, and we'll be able to transform the market. So if we think of it from like the successes that we've had, that have been driven by these types of rating systems, like on the material selection side of things. Think about material selection like 5-10 years ago or so, and the emphasis that was put on not just the carbon content, but on the quality, the VOCs, the off-gassing of those types of systems or materials. Those conversations weren't there. Manufacturers weren't widely sharing those types of disclosures. Now it's fairly commonplace in many markets to just be able to have that information. It's right there. You can go to your local home department store type thing and see that front and center on packaging. Energy Star labeled or appliances, WaterSense labeled fixtures. Those all are part of a overall push to just better educate, throw a symbol, market something that is, again, what we're considering. Just you need to be doing this for a broader reason. It just helps distill it down to a point where it's more easily understood. So we can lean into those kind of past successes of LEED or similar programs across the globe and adapt new water strategies that may be more commonplace in one region. To help that drive education and adoption in new markets. We're also thinking of like some of the heat pump technologies that are so commonplace in many parts of our world. And now we're just starting to see some resurgence back in the US where they're being better understood, not just from a commercial standpoint, but from a residential perspective. And with those types of things, you're also considering, okay, what maintenance training is needed on a contractor level to not just be able to install these types of systems, but to maintain them properly. It's a re-education of the marketplace too. And programs like LEED or other green building rating systems can help contribute and say, here are the best practices. Here's the tried and true process of stepping through these things. And we're now to a point where on the water efficiency side of things, we can start to ask what else and what else and what else, because we've done a lot of the, say, initial benchmarking. We've accomplished a significant amount on the water efficiency side of things. We have low flow flush fixtures. We have low flow flow fixtures, shower head design, better lavatory performance out of low overflow aerators. And we're finding a balance there where we can both achieve like the water cleanliness, the health hygiene aspect of it, while also being water efficient, putting a limit to that human behavior perspective of it as well. And again, shift into that and what else type conversation where we can get into, okay, where LEED and green building rating systems can shift from efficiency only to efficiency and alternative water sources like energy efficiency. Now we're shifting to renewables, where can we shift next from a water perspective, which downstream has that energy impact, that carbon impact. But we're looking not just, again, at a utility scale standpoint, but from an individual building, on-site control, on-site treatment opportunities. And if we have to use carbon as like carbon reporting, ESG benchmarking as a driving force to better, not just on the energy decision making side, but also the water side, I'm all for packaging the two together and just driving that conversation more that way. Is if that's a way that we need to revalue water, then I'm all for it. So now, like some of these things may conflict in some instances, like we're designing better energy systems. Well, what's the water cost? We want efficiency, but there's a water contribution. If we're using the tools these rating systems are working to deploy, like water balance models, energy models, run simultaneously, we at least are bringing water to the conversation, and having it contribute to the broader system design. So that's, I think, where LEED and other rating systems are best situated in saying, we've done this before. We have a long track record of doing this. This is how we can make these systems, and approaching the system, not just from an education perspective, but from a implementation pathway and benchmarking, what is considered that next evolution of, our building stock to push new construction design into better existing buildings.
Before giving the floor to Ayman, I want to add something, Rock, on our tag work. The water reporting is an important aspect from LEED that might come soon in the LEED. This is what I want to add from the LEED perspective. Giving the floor to Ayman to.
Hello. Yes, so let's take it from the beginning. Addressing the water impact at the building level involve implementing practices and technologies that promote the water efficiency, the conservation, and the reasonable use. And to dive deep into the LEED, for instance, within the LEED framework, you can be guided and assist to reach the sustainable building that you want. Under the water category, you can find many credits that will help and promote this kind of water management, starting from the indoor water management prerequisite and credit, where the credit promote the adoption of the high efficiency water fixtures and appliances, similarly to the outdoor water reduction, where the promoting of the sustainable landscape practices and smart irrigation system, in addition to adoption of the native plants. And by incorporating this strategy, building owners and occupants can make a significant effort to water conservation on the both global and local aspects. And from my opinion, achieving the LEED certification serves as a tangible demonstration of the commitment to sustainability and environmental responsibility. And it underscores the dedication of the building owner or the developer in the sustainable responsibility and sustainable practice that they are doing it. So one thing here also should be mentioned is that we should really start thinking that the government should make this kind of green building rating system as a mandatory requirement, at least for the minimum certification level. For example, if we took the LEED, it is not that hard to achieve the green level of the certification. And in this way, we can control this kind of behavior and practices. And we cannot allow anyone to design and build in his own. So I believe this should be a mandatory requirement for any building owner or developer in the region.
Thank you, Ayman. Back to Aaron. And it's estimated that a percentage of water is wasted when it's in coming to the building. Knowing that the wasted water is directly related to the carbon emissions, what are some of the strategies to mitigate the wasteful use of water?
Yeah, so I think the biggest thing that you can do up front is monitoring, put monitoring in place. The energy industry, I was thinking about this, how when I was growing up as a kid in the US, we had like a meter reader who would come by and read our meter every few months for our electricity bill. And now that is really changed because technology of meters has come a long way, and most electrical meters now in place read our pulse meters. They read electricity values every 5 seconds, every 15 seconds, every 5 minutes. But water has stayed the same. Like I was just a little bit surprised that so many of the facilities that I work with in the EU get a water bill once a year. And they have submeters in place in some cases, but those have to be read manually to be able to see what you're using, when you're using it, why you're using it. And so that makes it really challenging to identify what you need to do to reduce your water usage. So I think the first step would be to install smart meters. I'm working on a project now across a portfolio of data centers where we're doing that so that we can have real-time data. We connect it to our building management systems and see when we're using water, not just energy, but also water, and why, and what systems is that associated with it. And then you can make informed choices about where to invest in water reduction strategies in your facility. And I think the other thing related to that is developing water-specific KPIs. So I think every building is a little bit different. Every industry is a little bit different. But for example, in data centers, we use a metric called water usage effectiveness. So it's your water usage divided by your IT energy usage over the course of a year. And so this is a way to sort of track and compare yourself to how you were a year ago, if your production rates have increased or your the amount of servers that you have installed has increased. And so I think that is a really useful metric to determine in other industries, whether it's water usage per full-time employee or water usage per production unit or whatever it might be, that can give you some real baseline data and feedback, and then you can track that for ongoing performance. And make sure that you're setting targets. And in the industry of data centers, there are some targets being set in water stressed regions for WUE, and I would expect that trend to start to come into play for other industries as well.
Thank you, Aaron. Building from that, I want to hear from Daniel. What are the important questions to ask when thinking about water, energy, and access?
Yeah, this is okay. I do have my mic on this time. Thank you, and I apologize for that. The water energy nexus is something that we've tried to get our arms around forever. Water used versus electricity saved, and electricity saved versus water needed. How much water is needed to create energy. And again, this was very well teed up at the very beginning with the slides that shared those things. And, I'm not anti-LEED. Obviously, I've been a big proponent of the LEED rating system forever. But, we really need to start to, I want to compliment Erin on what she just shared. We can't really control what we don't measure and monitor. So in order to try and grasp this question, how do you improve? And I'm sharing, what about the policy of designing for net zero water? Or even, tighten your circularity approach. So even if you start considering net zero water, and again, I'm not in a literal desert, but we get at max 8 centimeters of water a year, less than 4 inches of water a year. And we've managed to design net positive water systems in that kind of a location. So how can we consider utilizing water more intelligently to both reduce the costs, a triplicate, reduce the costs, the energy, and the carbon impacts from our overuse of water. And in my big feel on this one is in Americas is really bad, and I'm sure Rock will agree with me. We use potable water for so much stuff that we don't really need it for, and then we dispose of potable water that we shouldn't be disposing. We should be using it for other things. Are we considering our best usage of water on our projects? You know, for example, is a project in an environment where evaporative cooling would benefit the project? Really, this is one of the key things that I keep advocating for in all these different rating systems around the planet. Understand the region that your project's going to be built in, because one size does not fit all. You know, it's a project, for example, in the Pacific Rim, in a high humidity area where we've got to worry about considerations for dehumidification. How does water benefit us there, and how do we not have a negative application related to the energy water nexus? You know, have we considered purple pipe water in its beneficial usage to help us soften our burden on the energy water nexus and in the embodied impacts of over-treating water, of getting rid of water that's still useful in retreating it? So what about it, considering that water is a living thing? You know, it supports our life. It supports the life of everything we eat and grow. So does that start to revise our opinion of the value of water? Because really we're missing out on that, in my view, the value of water. And what is our projects considered? As have they considered water capture, water reuse on the site, and even within our communities? You know, aquifers, it was really great posed earlier that, you know, aquifers are in really tough shape in the Middle East. You know, they're in need of our attention to be effective with our considerations. So what if we're, you know, overly prematurely removing that water from our building sites? And in contrast, we could employ a system that helps to recharge the aquifer there with water that's perfectly good for that use. You know, so there's a whole bunch of considerations I just shared, and with thanks to our committee, you know, of presenters here that have brought back and forward a whole bunch of really important things to consider. And you know, it's not lost. I think that we can really start to, if we're cognizant in our efforts to do it, and be willing to sort of expand our boundaries to see what's possible, let's get more use out of that precious living thing, to benefit, you know, our projects, our communities, and the planet.
Thank you, Daniel. To offer a different perspective, Rabia, what is the true value of water?
Oh, goodness me. I mean, it's life, isn't it? I mean, 70+% of our body is water. The same thing on the surface. I think it's life by itself. So, importance of it. I think, but I do go back to the point of where to use it. I think we've just developed this sort of excess of using it for non-essentials, and that needs to be tackled. One side of it. The second one is, we know that governments are less in charge, private sector are more moving into it. So water companies, they need to start to think from dealing with passive consumers to service customers to eventually having customers that they are stakeholders. And that is extremely important. And then the education has to be with the end user. It's like the same thing with the hierarchy of the energy. When we looked at passive design, efficiency, then renewables, the biggest chunk, the 50% required, is for our behavior, which is, that goes in line with monitoring, sub-metering. And I think if we want to make a big jump, because the time is against us, I think we can go and count 1.1, 1.11, and we can keep going for ages, being professional but not timely of what we are facing with the deadline that we have ahead of us. The biggest shift has to be in the human behavior. And that is one extremely crucial. How do we educate people? How to make them stewards? It's an important aspect of this. I mean, we're trying to work in our company on the transformation and regeneration. And one project that I've been part of is the Lake Chad. Now, Lake Chad used to be 25,000 square kilometers, and it's shrunk to 2,500 square kilometers, roughly about 6,000. It created every single havoc around it. You are talking about 10 to 15 million people that they have to really fight for more areas. They don't have enough agriculture. They have to have. Imagine if you take that and it created what we call it the insurgency and the problems, and creating this social chaos that led to further problem, even on the carbon side of it. Imagine if you take that picture and you say, all right, I'm applying that to 10-story building, and I'm saying to that building, instead of having 100 taps, you have just 10 taps. I will tell you, in the urban area, they will kill each other. So we're talking about here how to manage it, but that management require what we call it a leader, water leaders. On top of the sub-metering and monitoring, we need to have leaders, what we call them water leaders, across the whole sector, dealing with it from catchment area to the delivery.
Yeah, the champions, the water.
The champions, absolutely.
Yeah. Before we're coming to the end of the session, I want to hear from the audience. Do you have any question for the panel? Let's ask my final question. What other area of concern from water reuse or water quality that could have an impact on emissions? Aaron, you want to take this?
Yeah, sure. I thought about this a little bit as far as like waste generation and subsequent treatment on site through water filtration. I know that was in your diagram above, but my recollection from energy modeling is this is often excluded. And so I think that is something that is definitely a source of emissions that we don't have a full necessarily understanding of, those small pumps, that UV or reverse osmosis system, and the energy impacts of that water treatment on site. And then the other thing that I kind of had is construction water use, and particularly when water is trucked in with tankers or used for misting and things like that, kind of is there a ways to reuse that water on site multiple times? Because I've seen it's often not in construction for various reasons, but that feels like an opportunity. But the other thing that I was thinking about is kind of scope 3 emissions, which on the energy and carbon side is your downstream and upstream emissions. But outside of emissions, there's a lot of kind of water usage counted that exists both upstream and downstream. So like a building owner, their supply chain also has water impacts that are not necessarily easy to find that data or accounted for. So that's another area that I think could really be developed. I know there's some water footprint tools out there that help to account for this, but it does not feel like a mainstream thing where, for example, downstream, if you are recycling something for end of life, like there's water used in recycling plastics and recycling glass, and how do we account for that so that we have kind of like that full picture of the water usage associated with a project or a site?
Yeah, Aaron, I totally agree. And referring back to the presentation, the drinking water stream and the transportation and production of plastic and the glass, this is also to be added to the water carbon. It's not directly shown as water carbon, but this is a stream that by addressing the water quality and the bottle filling stations within the buildings, we can get rid and have all these reductions. Daniel, do you have any final thoughts? Do you need to add?
Yeah, I'm grateful that we've had this time to share our thoughts with, with the participants, and we could go on for hours, but I wanted to touch base on water quality. And we've all sort of touched down on looking at encouraging a great quantity of the planet's citizens that we can get much better water quality local with recovery and net zero water techniques when we don't depend on those concrete monuments that we know as water treatment plants. I was just in Cebu in the Philippines, within the last 2 weeks. One of my colleagues used our previous projects to inspire his work, designed a net zero water for a 0.7 hectare site. They treat all the water they need on site. In the purity and the quality is just unbelievable. They even use reverse osmosis to filter that water even more, run it through a ice making plant that's running on net positive energy on site. And they make ice only for a few hours every Sunday, you know, enough for them, for their consumption for the week. And then anybody who visits the site, you know, he's gifting away 6 or 8 liter or 6 or 8 kilo bags of ice to people. And it's the best quality water in all of Cebu because he's not adding, you know, chemicals to it to contaminate that living thing. It's really great to see both that water, that ability to do water reuse effectively and to have that really high quality. And then, you know, I wanted to return lastly to, we're not even considering in scope 3 emissions. You talked about the water bottles. And I wanted to share the initiatives for some conferences that gift out a water bottle and they have refilling stations. So we're not impacting that process. The other thing we didn't consider on those water bottles is they get thrown into the trash and half of them go into landfills or more. Less than 20% of them are recycled. You know, when we start to look at circularity and that carbon impact of just that habit that the planet didn't have 25 years ago, it's a really big, there's several opportunities for us to make really big positive impacts. I want to share some time for the rest of our team. Thank you so much.
Thank you, Ayman and Rock. Let me start with Ayman. Final thoughts.
I would like to emphasize more on what Rock said in the beginning. We all facing the same issue, however, with a different scale. And here in the Middle East, I believe we are the highest scale in this kind of challenges. Just to give you a taste about how much we are relying on the desalination plants here in the Middle East, taking the GCC countries as an example, where it alone accounts for more than 60% of the water desalination capacity in the world, with over than 400 desalination plants exist in the region. So different scale require different actions, in my opinion.
Rock, your final thoughts.
Yeah, yeah, there's been a wonderful discussion. I would go back to some of the prep conversations that we had and just kind of highlight a few things. We need better innovation for better passive design within our water systems. We need better efficiency. We need renewables from an alternative source perspective, how we're heating and moving and processing water. And we need to address the human behavior aspect of these. We need to be human behavior resilient in a sense where the human behavior it's very important and it's very variable. So adding some flexibility, it's a really, I guess, impactful way to think about like our water contribution and how we're using it. Our human impact on these things. Those are things that we need to emphasize. We need to see the value in it, but also be better able to kind of control the extent to where and how we're using that water. If we go beyond that, it's tackling leak detection, it's tackling missing data. To help make better decisions on these types of things. Again, we all are facing water challenges in different senses, and how we create that. To Raviv's point on how do we create what's our individual hierarchy of how we're addressing our water concerns. If we each kind of take that perspective in not just our personal lives, but our commercial, our business, our professional lives. We'll start to see those incremental impacts that we need to not just make water a second thought, but bring it to the forefront of like, if we don't have water, carbon doesn't really matter of what the carbon component of it is if we can't get the water itself when we need it. So that's all. Ibrahim, thanks so much for coordinating all of this.
Thank you, Rock. Erin, do you have any last words you need to add?
Yeah, I mean, I think everybody said all the good things.
Thank you.
But yeah, I agree with the holistic approach, and I feel very much that this kind of true value of water needs to be recognized and understood from the policymakers down to the users of water, and I think that's when this issue will become full circle and better addressed. But yeah, thank you for putting this together.
Rabia.
Yeah, I think just basically adding to what Rock was mentioning is that hierarchy, which is extremely important. Before tackling this, I think that hierarchy structure and the way we work in the energy sector is required to be really adopted in the water sector in a much, much better way than what it is today. I think before doing that hierarchy, it could be seen at the beginning like a linear thinking, is to have a proper mapping and the proper life cycle analysis to that drop of water from the beginning to the users. And once we establish that mesh of connectivity and interactions and algorithm of impact, including the carbon, the climate change, the biodiversity, that have to be all interlinked, we will start to really adopt a hierarchy in the thinking. And luckily, we have a lot of or more data coming across, but we need to more and more talk about the importance of water to everyone that you are meeting, and that is crucial.
Thank you, Rabia. We came to the end of the session today. We got perspectives from a comprehensive approach of the water energy nexus from US, UK, Europe, and the Middle East. Thank you for watching. Bye.